Hello, and welcome to the video. I'm Kira, and I will be your host as we explore today's topic of fusion versus fission, the big ideas, and why we should care. First, we will be talking about fusion, which is a reaction where two nuclei combine to form a larger nucleus and energy. This output of energy is the power source for stars. Fusion reactions take place in the innermost layer of the star known as the core. 90% of stars in the universe begin fusing hydrogen into helium. That means that this is the most common fusion reaction that we know of. To break down this process for you, for fusion to start in a star, the particles must be heated to a critical temperature. When this temperature is reached, fusion turns on like a switch. Looking at the specific example where hydrogen fuses into helium, once the switch is flipped, we will have a particle of deuterium and a particle of tritium, which are heavier versions of hydrogen. These will collide. After the collision, we will be left with a neutron, a helium atom, and energy. This energy is what powers the star. Multiple of these reactions are happening over and over and over again within the core of the star until all of the hydrogen has been used up. Fusion doesn't end with helium, it's really just the beginning. After hydrogen is fused into helium and all that remains in the core is the helium, more fusing will occur between helium atoms. This will fuse into heavier elements and heavier elements until the star's core reaches iron. Once fusion reaches iron, the core can no longer fuse iron together because the energy required to initiate the reaction is much more than the energy given off. That means that this reaction is very unproductive to power a star and therefore is where the star's life ends. Next, we are going to discuss fission, which in the simplest terms is the opposite reaction of fusion. Where in fusion we take smaller particles and combine them into larger ones, fission takes larger particles and breaks them into smaller nuclei and energy. This process is what's occurring within nuclear power plants. The plants take heavy elements and split them into smaller elements and then harvest the energy that comes from the reaction. This energy is then used as an alternative, cleaner energy source than commonly used fossil fuels. Some of the negative side effects of this reaction within power plants is radioactive waste. This waste is produced by the splitting apart of atoms, which causes radioactive material to be released. This material, unfortunately, is very difficult to store or get rid of in a safe manner. This causes this process to be unpopular for an alternative energy source due to the dangerous byproducts. Two of the more common elements used for fission are uranium and plutonium. This is because these are easier to initiate a reaction from and to control. The energy released by fission in these reactors heat water into a steam, which in turn is used to spin a turbine to produce carbon-free electricity. To initiate the process of fission of a uranium atom, a free neutron collides with the nucleus of uranium-235, causing the uranium to split into two smaller atoms of barium-144 and krypton-89, with the addition of three other neutrons. This process is self-sustaining because as it produces more free neutrons, they will be able to collide with more uranium atoms, causing the split to occur over and over again, releasing more and more energy and neutrons. A plutonium fission reaction is also initiated when a neutron collides with the nucleus of plutonium-239. This causes the atom to split into a xenon-134, a zirconium-103, and 3 neutrons. This reaction, too, is self-sufficient because it creates more free neutrons, which in turn can react with more plutonium-239s, causing the reaction to recur over and over again, creating more carbon-free electricity. Now for the overview. What is fission? What is fusion? And why should we care? Fusion is the reaction where two smaller nuclei combine to produce a heavier element, energy, and leftover neutrons. Fission is a reaction where a heavier nucleus collides with a single neutron, creating two or more smaller elements, energy, and single neutrons. We should care about both of these reactions because looking at the big picture, here on Earth, these could possibly be the answer to our energy crisis because both of these reactions produce clean carbon-free energy. Looking past Earth, we could also someday use these as a way to further explore the universe and where we live. With advancements in research, there are endless possibilities for the good that could come from these reactions. Thank you as the watcher for taking time out of your day to watch our video. I hope we gave you some food for thought.